Chemistry is awesome! Ladies and gentlemen, we have come to the last question of the day. Alright, question E. Determine the percentage yield if the actual mass of copper to nitrate obtained from the reaction is 0.85 grams. Okay.
Alright guys, okay. Before we can calculate the percentage yield, I think it's better let me explain to you. There are two terms first. So the first is theoretical yield. Right. So what is theoretical yield? Or in BM we call it as hasil theory. Yes, hasil theory, theoretical yield. Okay, so theoretical yield is defined as the amount of product that would result if all the limiting reactant reacted. Okay, for example, let's use this equation once again. Okay, the problem that we are discussing right now. Okay, so from the balance equation, we know that 1 mole of copper 2 oxide reacts with 2 moles of nitric acid to produce 1 mole of copper 2 nitrate and 1 mole of water. Okay, but in this reaction, we have 7 grams of copper 2 oxide, or in the form of moles, we have 0.088 moles of copper 2 oxide. And this amount of copper 2 oxide reacted with 0.01 mole of nitric acid, or 50 mils of 0.2 molar nitric acid, or if in the form of moles, we are going to get 0.01 mole. Okay, so just now we have already determined in this reaction, nitric acid is the limiting reactant, and that's why the moles of copper nitrate, okay, should be produced in this reaction will be or we can say that it depends, okay, on the moles of nitric acid. So that's why if the mole of nitric acid in this reaction is 0.01 mole, so theoretically we are going to get 0.005 moles of copper 2 nitrate, or in the form of masses, it is 0.9378 grams of copper 2 nitrate produced in this reaction. Okay, and this yield here, so that is what we call as theoretical yield. Okay, theoretical yield. So what is theoretical yield? Remember, so theoretical yield is the amount of product that would result if all the limiting reactant reacted. And remember guys, okay, so this theoretical yield of product is always determined or calculated from the balance equation. Okay, from the balance equation, and that is theoretical yield. Okay, right. So next is the actual yield or hasil sebenar. And just now is theoretical yield, hasil theory, and this time is actual yield, hasil sebenar. So what is actual yield? What is actual yield? So actual yield is defined as the amount of product actually obtained from a reaction. Okay, from a reaction. Okay, for example, okay, based on the theoretical yield just now, okay, if we have 7 grams of nitric acid, okay, or if we have if we have 0.088 moles of copper 2 oxide, okay, and 0.01 mole of nitric acid, so therefore the amount of copper nitrate, okay, that was produced in this reaction should be 0.005 moles or 0.9378 grams. Okay, the mass of copper 2 nitrate produced in this reaction, and this is the theoretical yield. So however, okay, in the actual reaction, okay, we don't get this 0.9378 grams that we should get, okay, for the mass of copper 2 nitrate. Instead, what we get is we only managed to get 0.85 grams. So this mass here, so this is what we call as actual yield. Okay, remember 0.9378 grams, that is the mass of copper nitrate that we should get based on the moles of copper copper 2 oxide and moles of nitric acid that we have. Okay, so we have 0.088 moles of copper 2 oxide and 0.01 mole of nitric acid. We should get 0.9378 grams of copper 2 nitrate. However, in the actual reaction, so let's say we only managed to get 0.85 grams. And this yield here, so this is what we call the actual yield. Please keep in mind, in any chemical reaction, for example, let's use this reaction that we are discussing now. Okay, so suppose if we have a copper 2 oxide reacts with 2 moles of nitric acid, yes, we should get copper 2 nitrate and water. Okay, so however, in the actual situation or in the actual reaction, sometimes a chemical reaction like this, such as this reaction, produces side products. Okay, side products. Okay, so that's why the amount of products that we should get, will be different. Will be different from what we actually get in this reaction, because of this reaction produce side products. And that is the case, that is the case why we are going to have two different yields. So that's why the actual yield and the theoretical yield is different in terms of the values or the quantities. So now is the time to look at what is the percentage yield. Okay, percentage yield, right? So percentage yield is defined as the actual yield, right? So the actual yield divided by theoretical yield and times with 100%. Okay, and remember, the actual yield and this theoretical yield, it could be either in grams or moles. It could be in grams or moles. Okay, right. And one more thing, remember, the value of percentage yield is always less than 100%. Okay, less than 100%, unless the reaction is the same with theoretical. But normally in a normal situation, we won't get percentage yield 100%. Normally it should be less than that. So that's why the percentage yield is normally the value is always less than 100%. Okay, so now let's look back at the question. Since we want to determine what is the percentage yield of this copper 2 nitrate. Okay, right. So remember, the theoretical yield was 0.9378 grams. Okay, so this is the theoretical yield, and this theoretical yield was determined through calculations, that we did in the previous question B and question C, right? And also question D, right? Okay, and then this 0.85 grams, the actual yield, and this was given in the question. Okay, so to calculate the percentage yield of copper 2 nitrate, so we know that the actual yield divided by theoretical yield, times 100%. Okay, so remember guys, so this actual yield and theoretical yield, you have two options, whether you want to use the moles or you want to use the grams. Okay, it is not necessary to use grams. Actually, we can also use moles, but in this case, I'm going to use the masses, or in grams. Okay, so the actual yield is 0.85 grams. Okay, so divide by 0.9378 grams times 100%, and we are going to get, right, 90.64%. And that is, guys, and that is the percentage yield of copper to nitrate. It is just 90.64%. Okay, so that is how we calculate percentage yield. Alright guys, so let's summarize what you have learned. Okay, so the first part of this lesson, okay, you have learned on the definition of limiting reactant, and also the definition of the percentage yield. Okay, and then we also have already discussed the question. In this question, you need to perform stoichiometric calculation using mole concept to determine the limiting reactant and to determine the excess reactant. And also, just now in the last question, we have also have a look at how to calculate percentage yield. Okay, so that's all for today's lesson. And in the next lesson, guys, we are going to enter Chapter 2, because we have already finished with Chapter 1, Matter. Okay, so in the next chapter, okay, we are going to enter the new or the second chapter of this chemistry SK015, which is atomic structure. Alright, so that's all for now. Thank you for watching, and I'll be seeing you again in the next video, inshallah. Bye bye.